Who knows what the word perimeter means? If I asked you to get me the perimeter, if I give you a ruler and I ask you to get me the perimeter, just wait a minute, perimeter of this piece of paper, what do you measure? One side or all the sides? Exact. So what do you call it? The outline or the what? Or the outside border of it. Perfect. How about the word area? What's the difference between perimeter and area? What's the inside? Perfect. Everyone. So Carly perfectly nailed it here. Listen up. The perimeter is the outside length, and the area is the inside space, I guess. So let's write this down. So perimeter. Okay, everyone, let's copy. So perimeter. Perimeter is the outside. Zoe, come on, please. Is the outside length. So if you sketch absolutely any shape and you want the outside length, you just walk outside and you see how long the entire shape is. So outside length or the addition of all sides. Guys, I'm talking. Thank you. Or the addition of all sides. Okay. Area, guys. I don't want to keep saying guys all the time. Please. Thank you. Area is the, now we can't say outside, now we have to say the what? The inside space. Or we can say what? The size of the region. The size of the region. You know, when you buy a house, you're always interested in the what? In the area more than the perimeter. If you're buying a fence, then you're interested in the what? In the perimeter more than the area of the fence. Okay, so the question now is, how many shapes are we responsible for? How many shapes are we responsible for in this course? Well, the good news is not so many. We're only responsible for 4 shapes. That's it. Okay, only 4 shapes. Are there more than 4 shapes? Of course. We could say there's like 8 or 9 or 10. Depends on how complicated you look at it. Okay, so what are the shapes that we're going to be interested in? Well, according to this chart, and by the way, you're all going to have this chart on you to help you with the calculation. So there is need to memorize the equations, but you still need to know how to what? Plug them in. So the first shape we're going to be interested in is a rectangle. What's a perfect rectangle? What if you have a rectangle with all identical sides? What do you call that? A square. So that's why I did not put a rectangle and a square. I just put rectangle. The next one is a triangle. Probably the third one is the one that's going to be new to most of you. Has anyone have heard of a trapezoid before? Raise your hand if you heard of a trapezoid. Yes. And obviously the fourth one is probably one of the most famous one, a perfect circle. A perfect circle. Okay. So let's look at the first shape. Let's look at the first shape. Let's look at the first shape. How many sides does a rectangle have? How many sides does a rectangle have? How many sides does a rectangle have? 4. What can you tell about each one of the 2 sides? What can you tell about those 2 sides? Does anyone know what those signals mean or their symbols? They're what? They're equal. So you have to say that this side is equal to this side, and also what? This side is equal to this side. What do you call the longest side in a triangle? Sorry, rectangle. What's a good name? Well, we can call it the long side, but we can call it just what? Length. So everyone, we will call this length. Length. But we are math people. We don't want to keep calling it length all the time. So we're just going to call it capital L. So I just want you to write length, though. So if this one's length, what's the other one? There you go. So, oops, sorry. Width, W-I-D-T-H. And the symbol would be, by the way, I tend to use capital letters. I find them easier to write. Capital W. Well, what does that mean? This is also another length, and this is also another width. So now we're not going to write the words, we're just going to write the symbols. So go ahead and put W here. And then length here. You know what? I think it's better to put the W regularly, like not like this, sorry. Probably this is a good way now. Yes. So everyone, erase it and just write it like this. Okay? LW, LW. Okay. How do you get the full perimeter of this? What do you do with those four sides? What you add them up. So explanation, everyone. Under explanation, not equation yet, just under explanation, right? Perimeter is the addition of all four sides. Okay, equals. Okay, I like to add L plus W plus W. I just get the L's done first. So L plus W plus W. There's an easier way to write this. 2L plus 2W. Much easier than that. Zoe, Carly, can you copy, please? Thank you. Okay. Does anyone know how to calculate the area of any rectangle? Like if I told you, get me the area of this. By the way, again, this is a life skill. If you leave high school without knowing how to calculate the area of a rectangle, you're truly not ready for so much in life. So who can tell me how to get the area of this rectangle? I'll give you a hint. It depends on the length and the width. But what do you do with those two numbers? You multiply them. So area is the multiplication, sorry, the multiplication of length and done. That's it. So what's the equation now? A equals length times width. Done. Could you actually multiply width times length? Of course you can, but you will always hear it length times width. Everyone's going to say always length times width. What's up? Guys? You're distracting me. I can't really focus when I teach, so thank you. So, but oh, sorry, this is area, not R. Area. Sorry. Area. That's it. That's all we need to know for what? For rectangles. What's the next shape? What's the next shape down the chart? Triangle. Okay. So I'm just going to wait until everyone's done copying. Okay. Just 1 second. Don't worry. Here you go. Come on. Area is the multiplication of length and width. Okay. Let's go to the next shape. Oh, Anthony, here's the equation. There you go. Just A equals L times width. Make sure that it's a times, not an X. It's like a very small times sign. Okay, next shape, triangle. How many sides does a triangle have? Okay, so let's call them what, everyone? We are going to call this, I want you to do this. So let's, there we go. We're going to call this side 1. So side 1. So I'm going to call it S1. S1. This would be what? Side 2. Go ahead. Side 2. Which means this one will be actually, I'm not going to call it side 3. I'm going to call it a very special name. I'm going to call it the base. So everyone go ahead and call it base. B A S E. Go ahead. Base. Okay. If I gave you this shape and I ask you to calculate the perimeter, what do you just do with the 3 sides? No. Perimeter. Perimeter, you just what? Remember me walking. Add. How many sides though this time? Exactly. You add side 1, side 2, side 3. So everyone, here is the equation. Sorry. Here it is. Perimeter is side 1 plus side 2. By the way, I don't care if your S is capital or small. Doesn't matter. As long as you tell me there's an S1, that's side 1. There's an S2 for side 2. And there's a B for the base. And technically, I can't even take marks off if you don't call it base, if you call it side 3. That's fine. I just like to give it a very special name because it's a very special side. Okay? So what's the explanation for this equation? Just like the explanation of the rectangle, the only difference is instead of saying you're adding 4 sides, you're only adding how many now? You're adding 3. You are adding 3. Okay? All right. So that takes care of the easy perimeter of a triangle, which again is not a big surprise. You just add 3 sides together. What is the area, everyone? What is the area of any triangle? You're almost there. There's, by the way, what you forgot, don't feel bad, is something that so many of my grade 11 and 12 math students also forgot when they did their geometry test just last week. Base times height divided by 2. You always divide the multiplication by 2. That's why you need the height. You don't just need the base, you also need the height. So in any triangle, go ahead, everyone. In any triangle, like let's say, for example, you are building a tent. Everyone, you're building a tent. Obviously, a tent looks like, I mean, it could look like a pyramid. But let's say it actually looks like a legit tent. So it looks like this. Oops, sorry. It looks like this. Let me just minimize this. And new. I guess a tent could look like this. Oops, sorry. Brush. Yeah, there we go. Maybe this is the entrance of the tent, right? I mean, the tent usually has what? Has a triangular entrance. And then, oh, that's that. Yep, you're right. And maybe this is the body of the tent. I mean, come on, I've been practicing for close to what 35 years.
Yeah, that looks better than what I would ever be able to do.
And I had teachers who always sketched. Always, always sketch. And also, no, no, okay, you have to factor it from my experience. I've been doing 35. I had teachers who always sketched. I belong to a different generation where we sketched a lot. Technology and cell phones were not there. That was good for our, dexterity and sketching. Also, I have a physics degree. And in physics and science, like with Mr. Orwood, you always sketch, right? You're always sketching. You always take a big bunch of like words and a word problem, and you're like, I didn't need to read all this. Just sketch me a diagram that kind of tells me what's going on. Perfect, done. Again, my students in physics always. Yeah, exactly. But you know what? Sometimes I have it for some students, and sometimes I don't. But if you actually look at sometimes, at the end of well, I guess next year. She's just taken like this term is a term leave of absence. Just this term. She's come back. Now, what shape is this? It's a triangle. The entrance of a tent is usually a triangle. If I want to know how big this triangle is, what did I just tell you need to know? You need to know the base of this triangle or how wide it is. Like this. Oh, I can't split. Trust. You also need the what? The height, like the zipper from the whole thing. And then you divide by, you have to divide by 2. If you don't, you're going to get double of what the real area is, right? Because remember, when you divide by 2, things go down to half. When you don't divide by 2, they stay as big as they were before they divide by 2. So, yes. So, area is, okay, now things are what? Not as straightforward as a rectangle. A rectangle was just what? Multiplication of length and width. Area is 2 steps. First, you multiply. By the way, you can't call it length and width. You always call it base and height. So area is the multiplication of base and height. But then what do? What do you do? Then you have got to divide by 2. Again, we have so many examples on the other 2 sides of the sheet. So we'll see exactly how this translates to real numbers. Okay? But please, if there's a take-home message about triangles today, is that if you want to know how big a triangle is, area-wise, you need to divide by 2 at the end of the multiplication. Forgetting to divide by 2 does not give you 0. You just lose what? You just lose like maybe a mark out of the whole question because your answer is twice as big as what it should be. Okay. Sarah, what's shape number 3? Trapezoid. How many people have heard of a trapezoid before? Can someone tell me just by looking how different? So okay, okay. Here's an easier way to ask the question. I want you to compare a trapezoid to a rectangle. Compare the. It's what? I love that. Exactly. It's what? Slanted. What does slant mean? What's another word? What's another word for slant? Actually, they are straight. But what you mean is okay. Starts with T. Tilted. Or okay. Why do you have? I am not even using big words. Okay. So but by the way, a trapezoid still has how many sides? Look. So we went from 4 to 3 to another 4. Okay. So everyone, what kind of black magic are you doing? Okay. Here's a trapezoid. 4 sides. Why do you think I'm not calling the top and the bottom side S1, S2, sorry, S3 and S4? Because they are so, okay, question everyone. Can you tell me, if I hold two pencils like this, what do you call two pencils or two lines? Everyone, eyes on me. What do you call two lines that look like this? Look, Jalil. Actually, now they're vertical. Horizontal. They're what? Are they still parallel? Yeah. So, by the way, parallel lines never what? Never cross or never meet. Question. Is this one parallel to this one? Just look. Is A parallel to B? Absolutely. Is S1 parallel to S2? Okay. Question. Everyone, look. Are those two pencils parallel now? Yeah, because they will never meet, right? Are you with me? How about those two pencils? Are they parallel? Why not? Because if I keep moving them, eventually what's going to happen? Yeah, see, parallel lines don't have to meet in front of you. You just need to know that they meet if you what? If you keep going or extended them. And we know for a fact that that will happen to those. So what can you tell me about a trapezoid? Two sides are parallel, but two sides are not parallel, right? How about a rectangle? Look at the rectangle. Each two sides are what? Are parallel. So that means what? That's how different a rectangle is from a trapezoid. A rectangle has those two never meeting, and also what? Had those two never meeting. How about a trapezoid? Those two never meet, but how about the other two sides? Yes, they either look like this or this, but they have to meet. If you make them not meet, you created a what? A rectangle again. All right. Or a what? Or no, but or a square, which is the most perfect rectangle. Still four corners, 90, but same. Yes. Okay. How many sides do we have here? Not counting the inside height. By the way, you never count anything on the inside for perimeter, because perimeter is always where? Outside. Perfect. You see, you're telling yourself, if it's outside, why should I care how big the inside height is? So how many sides do we have? I call this A and B because to me they are so special. They are parallel bases. This is the parallel ceiling. Sorry, this is the top ceiling. This is the bottom base or the bottom ground. This could be the left side. This could be the right side. So what's the equation for the perimeter? Addition in any way you want. S1 plus S2 plus A plus B. Let me see how I did it. I did A plus B plus S1 plus S2. Done. That's it. So exactly the same explanation, but as a what? As a rectangle. Perimeter is the addition of all four sides. Remember, perimeter biggest mistake is people either undercount a side or overcount a side, which means you either get a smaller addition than what you need or a bigger addition than what you need. Okay. Okay, everyone, what was the area for a rectangle? Just what? It's the easiest. What? Length times width. Do you think? Do you think this is gonna be as simple? No, because not all sides are parallel. Okay, everyone. It's gonna be probably the most complicated one in this sheet. Everyone, here it is. Ready? 3, 2, 1. That's fine. Let's no. Let's look at it and try to understand it. Apparently, what's the first thing you do? Come on, with me. You add what? A and okay, you're done. You're done with the addition. What happens next? You multiply whatever you got here when you added, you multiply by what? And then, so apparently the divide by 2 trick. No, you know what? Not only that, when you say it the way I did, and we look, oh, so first I do this, second I do that,
Third, I divide by. That's it. It's only 3 steps. You just have to do them in the proper order of the steps. You need to add first. Once you add, once you get this addition, like let's say 6 plus 7. 6 plus 7 is 13. Great. That thing is 13 now. We don't even care about the A and B because it just added to 13. 13 times whatever the height is. Let's say the height is 10. 13 times 10 is 130. And then you slash it by what? That's it. Done. So area of a trapezoid is the exact. So it's 3 things. Number 1 is the addition of top and bottom, because A was the top, B and the bottom. I mean, you could have called it the other way. Then multiplied by height, then divided by 2. You do it in this exact order, you will never make a mistake in your final answer. Okay, what's my last shape? The most perfect shape in the universe, a circle. The only shape that is completely cornerless. Okay? The only shape that is completely cornerless. Okay. It's so special. By the way, yeah, go ahead. Oh, no, but before that, it was the only shape that did not have straight geometry or sharp corners that was understood for like in humanities math for like years until the 1600s when more advanced math was invented, and then more curved shapes were understood. But for years, for centuries, not for centuries, for millennia actually, we only knew how to deal with a circle. But it's a good thing, it's a perfect thing. Sarah, what do you want to say? Yes, and everyone, what is the most famous symbol whenever you deal with a circle? Starts with P. P sign. Pi. No, but pi is the symbol, right? Does anyone know what pi is? Oh, interesting. She remembers that. By the no. Actually, we already discussed that. Again, remember what I always say. I built a career as a math and physics teacher. For what? By just. But I built a career of a good career of being a math and physics teacher by only knowing 5 digits after the 3. 3.14159. Great. And did I tell you that there are they like it is infinite. Also, it never repeats. They have proven it doesn't have what you call it a repeating block. A repeating, like for example, I'll show you what I mean. Yeah, like a copy paste nature to it. So let's say, for example, what's 7? No, not 4 divided by 7. I think we dealt with this fraction before. Look at 4 divided by 7. 571428. 571428. Is there a repeating block? Yes, there is. Where? Those six digits right here. You keep copy pasting, you've got the number known forever. Pi does not have that. It doesn't have any block, no matter how big, no matter how small, that actually repeats anywhere, which means you need supercomputers to calculate any digit of its infinite digit collection. Also, but here's a question for everyone. What do you need to know about a circle? You only need to know one thing to understand everything about a circle. No, one thing about its measurements. Like for example, what did you need to know about? Listen up, everyone. What did you need to know about a rectangle? Length and. By the way, if you flip the triangle this way, it becomes length and height, right? But let's just call it length and width. What did you need to know about a triangle? Side 1, side 2, and what? The base, side 3, and also the what? The height. What did you need to know about a trapezoid? Side 1, everyone look at me. Side 1, keep going. Side 2, A, and you only need to know one thing about a circle. Okay, everyone. Who? Whoa. You mean there are 360 degrees inside of it, not out. Like it. By the way, if this has 360 sides, it's not a circle. You know why? It might look like a circle, but if you zoom in, you're gonna see very sharp corners. Oh, okay. You know what? Let's build us a circle. You're almost there.
Well, I'm just trying to go through my brain. Remember grade 7 and 8, now grade 10.
Can someone tell me what's this? What do I call this point right here? Bullseye, middle. One more. Center. Okay.
Well, if you're shooting target.
Okay. Does anyone know what we call this line? Everyone focus with me here. Last thing for today. What do you call a line that perfectly cuts a circle, any circle, in half? It cuts it into two slices. I'm not saying that. That's wrong. But what do you call that red line? By the way, well, as not quite. Is it because you just saw it here? By the way, which I mean, which I could. By the way, it's also this line. Okay. It's also this line. What do you call all of these lines that perfectly cut the circle in two? I'll give you a hint. Diagonal is when you cut a square or rectangle, like tilted, right? Like from corner to the other corner. Take it. Diagram is just a shape. How many people have heard of the, listen up, diameter?
Oh, yeah.
A diameter of a circle is the line that goes from one side to the what? To the other side, but it has to pass through the what? A very big mistake. Everyone, a very big mistake is people think this is a diameter. Look, is this a diameter?
No.
By the way, two ways. No, you're right. Two ways to understand this. You could argue that this is not a diameter because it doesn't go through the what? Come on, it doesn't go through the what? The center of the bullseye. Here's another argument. If you cut a pizza like this, are you dividing it into two identical halves?
No.
Of course not. So what's another way to think of a diameter? A diameter is a line that cuts it into an upper half, two equal or two even parts. That's what we call a what? Come on. Diameter. How do you spell diameter? Okay, everyone look.
Oh.
Easy. Trust.
Hang on.
D. Come on. D. By the way, don't everyone, don't add this to your sheet. D I. Come on, everyone, eyes on the screen. D I M. Diameter. Okay. Okay. I want everyone eyes on the screen. What would I call it if I do this? Look. Give me a second. What if I only focus on half of it? Because that word is the word we need to know. Obviously, can you call it diameter anymore? No, a diameter is full from one side to the other side. I am apparently only looking at half of that. Does anyone know what you call half a diameter? Say again? I'll give you a hint. It starts with R. And it's actually a name for a what? For a bone in your body. This is it. No, radius is ulna and radius. Yes, radius is this one. Radius. Thank you. The radius of the circle is the distance from where to where? From the what? To where? Does it matter where it points? No, it matters where it starts from, which means starts from the where. So the radius is the distance from where to where? From where? From center to the what? To the edge of the circle. Doesn't matter which way it points. No, you have an infinite collection of radiuses to go. As long as you start from where? What if you do the whole thing? You can't call it radius anymore. You call it what? diameter. Is it making sense now? So diameter cuts it all. Radius goes only from center to the edge or the rim of the circle. Good. Oh, I can teach you a very easy way of finding the center of any circle. Just hold on. Let me finish this one. Now, what I want you to do now, okay. Oh yeah, I should have actually shown you where the center is. Okay. Let's guess it. Okay. By the way, you will never have to guess the center. I know, but if you, how do you perfectly find it? That's the key. So everyone, let's just say it's here. Everyone, just choose a dot somewhere in the center and just put it there. By the way, you will never have to guess the center. I will always put a center point for you because you need to start from it. Okay. What did we say we have to sketch? Do we sketch a full diameter or just a radius? Yes. Everyone, can you sketch a diameter? You could. Exactly, because you're going to end up erasing half of it. So just start from the center and just sketch a radius. So who needs rulers here? Okay, you really don't. Where's the thing? At the back. The rulers, the big rulers are. Oh, you have one? Okay, good. Here's one. Okay, good. Again, it's a very small distance, so you don't need much. Oops. Oh, you have one? Okay, good. You just need a sharp edge. Even any sharp edge will do. Okay. So, which radius should we sketch? Does it really matter? No. I just want you to sketch a distance or a line from the center of the circle to the edge of the circle. So, for example, by the way, how you sketch it tells me something about how organized you are. Sarah apparently sketched this one, like a purely vertical one. Other people might sketch what? A purely what? Horizontal one. It doesn't matter. They're all radiuses. So I'm going to choose now to sketch. Everyone, look. I'm going to choose now to sketch from here to here. Go ahead. Now, does anyone know how to spell radius?
R-A-D-I.
Yeah.
O-U-S.
No O. Just you.
I-U-S.
6 letters. R-A-D-I-U-S. So everyone go ahead and write radius. R-A-D-U-I-S. What do you think the symbol for radius is? No, you're right. R. I've seen people do it uppercase R, like capital, and I've seen people do lower. I like to use lower. So I want you to put R here. That's it. Go ahead, come on. Okay. You yes, by the way, the biggest, and Ms. Davila could tell you that as well from her years of studying and touring. The biggest, the two equations that people mostly confuse together are the perimeter of a circle and the area of a circle. Why? Because it depends. But they look almost the same, but where you place the two is where so many people get confused. Okay, but first of all, does anyone know what's the special name we give to the perimeter of a circle? Listen up, come on, sir. What is this? What is the special name? By the way, we can call it perimeter. Everyone, look. If you stand here and you hold a string and you walk perfectly, obviously, until you get here. That is the perimeter of the circle, right? Because that's the same way I got the perimeter of this desk. But the circle is so special, it has a special name for its perimeter. No other shape has a special name for perimeter except the circle. All of them are called perimeters. Perimeter of a square, perimeter of a pentagon, perimeter of a star. But a circle could be called perimeter, but it has a special name. You know? Sure. I'll give you a hint. Starts with a C. Say again? Compass actually is this guy. No. Compass is this guy. Compass aside from the compass you use for directions. Compass is actually, this is a compass, right? Yeah, everyone, this is a compass. A compass is the thing you put a pencil in, and you choose how big your radius is, and you just go around. How many people have heard of something called, before Julia leaves? No, no. But what do you call the full distance? How many people have heard of a circumference? That's it. Circumference is the only name given to a what? Circumference is only for what shape? You can never say circumference of a square or circumference of a triangle. You only can say what? Perimeter of those things. Now, does anyone know how to spell circumference? Probably not. Okay, wait. Hold on. C I R C U M, ference. It's a long word. CE. Obviously, we're only going to use what letter? We're going to use what letter? Small or capital? Always capital C. All right. Uppercase C for circumference. Okay, come on. So, everyone, I'm showing you multiple what? Multiple choices of radius. You could go here. You could go here. You could go. It doesn't matter. Just go from the center somewhere. So the name of it is. There we go. This is the equation. If you want to know how, I don't want to say how big, but how much distance is around the circle, if you want to walk it, you just multiply 2 times. Again, Sarah, what is the value of, and what is that symbol? Pi. By the way, some people like to write this. Everyone, if you like to write it this way, you don't have to. You can write this. Oh, like this. Good. Everyone, look, everyone. This line. That's it. That's fine. Obviously, you could get fancy. Look, Jake. This is the fancy way of doing it.
I do that. I really honestly do that.
Again, it depends on the font, but please don't bother. Just do this. Done. So 2 times pi times what? Times r. That's it. So perimeter of a circle is called the what? What was this word again? Circumference. CIRCUM FERENCE. Obviously, we just call it capital C. Okay? 2 times pi times radius. Done. That's it. And let's actually prove it. How can we prove that? Do we have anything? I just need something that basically has a what? Has a circle base. But I need it to be somewhat big, I guess. If I can take it off. Oh. No, I want a circular base, man. Oh no, I don't want to. I don't want to touch this. There we go. All right.
Paper plate, really?
Yeah. It's a perfect circle, right? Okay. Look. Okay. Come on. What am I gonna do here? I'm gonna wrap a what? Wrap this around the what? Around the circle. How many times? 1 and only once. Okay. I believe this might be enough. Yes, I'll cut this much. Okay. Cut much. Where's this? There we go. Okay, Jake, I need your help. Come on. Okay, so everyone, what we're going to do is we need to actually just make sure that we have, okay, we just need like an anchor to start from and go to. So I'm going to anchor it right here. Yeah.
and I want you to hold it. Go. Just hold and push in. Not much.
Don't
Right.
damage
It's like
the
he's trying to
table,
kill the
kid.
plate.
All right.
No, I was trying
Okay.
to cut the table.
All right. I'm gonna make sure I start exactly here. Yeah, go ahead. Push, push. Oops. Sorry. All right. We need to make sure that it's here perfectly, like it doesn't go in. All right. Okay, Sarah, I need your help too. Come on.
We're not making a bomb.
No, I need you to just press on the plate.
Yes. Easy, hold it.
Okay. Don't think is it press so hard so it doesn't actually like. Yes, 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 yes. I'm gonna tell you when to lift it up. Okay, done. Lift. That's it. That's it. Yep. That's it.
Oh, that's
So I am saying that this much right here is the what? Is the circle.
What the?
your table's stronger than that.
Okay. Who has a long ruler? Jalil has, actually. Okay, everyone, I'm going to measure the what? The length. Sit down, sit down. Okay, I'm going to measure the length. How long is this? Well, this part is 30. Okay, Ty, I need your help. No, I just want to make sure I have it extended. Okay, I want you to measure from here. Okay, so how long is this? Yep, 130. Okay, and then okay, get your pencil. Okay, get your pencil. Go get your pencil.
Bending something and making it. Yeah.
Okay, so no, we have to make it perfectly. Okay, no, wait, we have to. Okay, mark the 30. No, the 30 right here. 30. Yes. Okay, now measure from there to the end. Can you see it? Okay. No, start from 0. Oh, yep. How much? 22 point something, 23. Okay, so everyone, the circumference of that plate is 30 plus 23-ish, which is about what? Sorry, 53. 53 what? 53 centimeters. Okay. What was the equation anyway? 2 times what? Times, I need to find the radius of this. Like, I need to find the radius of this. So this is what I'm going to do. I need a blank piece of paper. I need a blank piece of paper. Because I'm going to try to trace this plate. I'm going to try to trace it. A plate's not the best. Because, okay, well, let's see. Okay, we're ready? Circle? What do you think? Because I traced a circle. I traced already a round shape. Okay, I need now to find what? The radius or the center of it. First, I need to find the center. Okay, I'll show you actually a very neat trick to finding center of any circle. Everyone, look, check this out. What do I have in my hand? What do I have in my hand? Okay, I'm gonna put the triangle anywhere I want on the circle. Oops. Without dropping it, yes, Mr. Clumsy. Okay, look. Is it touching the circle? Okay. Okay. Check this out. Wait. Do you see this? What's this angle? No, this angle. 90. Do you think this line cuts it in half?
Maybe.
Come on, just look. Do you think the base of this triangle cuts the circle in half? What is the full line that cuts the circle in half? Diameter. I don't want diameter. I want only what? How much is the radius compared to the diameter? Half of it. I'm just going to measure half of this. That's it. Works every time. So 0, 2. Okay, I need someone to divide something for me. I want you to divide 17 and a half. No, 17.7. 17.7 divide by 2. 8 point. So 8.9-ish. Does this look like the center? What do you think? Yep. You know what? I can prove it to you another way. Check this out. No, look. I'm going to make another triangle, random one. You pick the point. You pick. Where do you want to put the one to put this corner here? Okay, you point to it. Okay, like here?
Yeah.
Okay, everyone.
Not perfect.
I'm going to do the same thing. I'm going to prove to you that those two lines are going to meet at the same point, which is the circle, at the center of the circle. All right.
I just pointed to a random spot.
It has to work no matter where you point. That's the beautiful thing about it. Is that a 90-degree corner? That's all that has to be there. 90 degrees. 90 degrees. What are you doing?
Oy, oy, oy.
What do I do now? Come on. What do I do? I connect here to where? Did it almost go through the center? If my triangles were perfect, would it have perfectly
Well,
gone?
it's not perfectly in the middle, but it's close
No,
enough.
but that's my point. If everything was good, it would what? It would be perfectly in the middle. So now I need to measure the, okay, we measure the radius. How much was the radius? I told you to divide. What'd you get? Radius equals how much? 8.85 centimeters. So everyone, look, everyone, eyes on me. Apparently the radius of this circle is how much? 8.85. Okay, well, you know what? Apparently, I can apply this equation. Let's do it. I am trying to prove to you that, look, I'm trying to prove to you that you do not need to get a string every time and what? And go around. You can just apply this equation, but you still need to know the what? Come on. Still need to know the what? Okay, let's multiply. Oh, yeah. 2 times 3.14 times 8.85. How much is the answer? How much did I estimate? Close enough? Yeah. Again, when I wrapped, do you think my wrapping was perfect? No, because it actually what? Did it go in a little bit? Yeah. Even with Jessica Sarah pressing so much. Sorry. Even so. Do you know Jessica?
Yes, I know. Jessica.
From-
She's
yes.
really there.
And there is a resemblance. That's why I taught her before.
Exactly. That's why people keep asking me
Yes.
if I'm Jessica. I'm like, no.
The first time I actually saw, remember when I
dropped?
remember when I dropped by for Miss Dorort? I was taking attendance. I was like, that's not the same last name as Jessica. I swear I thought they were sisters. Okay?
People always get that with
Okay. Come on, everyone. That's the what? That's the circumference. How about the area? Okay. You know what's going to happen to this too? Yes, it's going to climb up here. See, that's why so many people what made the mistake. It depends where the 2 is. If the 2 is at the beginning, it's what? It's what? Circumference. If the 2 is on top of the R, it's what? Fire, which is area. Exactly. There you go. Everyone, come on, come on. Last thing for today. If you do this equation, by the way, I'm going to put the 2 equations next to each other to see how similar yet different they are. Is there a 3.14 here? Is there a 3.14 here? Is there an R here? Is there an R here? Is there a 2 here? Is there a 2 here? But where is the 2 here? It's at the beginning, right? Where's the 2 here? It's at the what? There you go. Yep.
Don't fall over, Mr. Robert. Why is it going through
Not dump. Don't get over by group.
Okay, whoa, hold on. 5 minutes. Just so area of a circle is what? The radius. What first? What's first? You have to square the radius or multiply it by itself, and then you multiply by what? Come on. Multiply by what? 3.14.
Multiply it by pi.
Pi. Finally,
No.
finally, the units.
Always go
The units. How do you measure perimeter or length? Well, you can use any of those words, or sorry, any of those, I should say what? Units. You can use, what's the first one? Is it meters? Centimeters. You can use what? Meters, inches, anything that measures straight length. How about area? You use the same thing, but you have to put what? Okay? Light years, because light years tells you how far something is. So light years is technically a measure of what? Distance or perimeter. Yeah? But how do you measure? How do you measure area? You use the same thing, but you have to put what on top? Why? Because you talk about squared centimeters. When you buy a house or rent an apartment, what do you always ask about? The square what? This, yeah, the square footage. You never ask about the footage. You always have to say the square footage because no. It's a 2D shape. Remember, everyone, look. But no, Sarah, you said 3D because an apartment is 3D, right? I'm not talking about the apartment. I'm talking about the floor of the apartment. It is what? It's 2-dimensional. That's why you just ask, how wide is the floor? So they tell you, oh, it's 7,000. Oh, that's big. It's like 1,200. 1,200 square feet. Square feet, 1,200, which is kind of what mid-size apartment. Mid-size apartment. Okay. So always remember, everyone, for area, you need to write what? You need to write what? The 2 on top, the square. And when you talk, you have to say it. When you calculate, you have to put it here. When you do perimeter, is there a square? No, because how can you square a perimeter? A perimeter is just, oh, I just went around and I had a string, and the length of the string is yada, whatever. Okay. Yes, I do. 1 second here. Let me just